So let's work on the homework problem. So you are given 5 instructions. We're gonna fit this 5 instruction into pipeline. And you are also given register contents and memory contents. In cycle number 1, the move instruction is gonna go into the first stage. Right? And then cycle number 2, move instruction is going into register file, and then LDR is gonna go in here. And then cycle number 3, move instruction is ALU, and then LDR instruction is in the register file, and then STR instruction is gonna be in. In cycle number 4, move instruction is gonna go getting into data memory stage, and then LDR, and then STR, and then ORR is gonna getting into the instruction memory state. And cycle number 5. So cycle number 5. Now we need to find the proper values for those highlighted places. Typically, it is a good idea to work on backward. So you need to work on the move, because move instruction is the last stage. Let's take a look at them. So move 0x2c into R1. So the content of result W is gonna be 2c, because that's the content of R1. So that means WA3W is gonna be 1, and result W is gonna be 0x2c. That's the hexa number 2c. Subtract R1 minus 8. So what we have, R1 actually start with OX 1 and 1. However, we updated R1 because we move 2C into R1. So new value of R1 is now 2C. So R1 is 2C 00101100. That's 2C minus 8. So we need to find the 8 first. 00001000. That's positive 8. Negative 8 is gonna be 11111000, and then we add 0 0 1 0 carry 1 0 carry 1 1 carry 1 0 carry 1 0 and carry 1. So it's gonna be 2 4. So ALU out M is gonna be 0x24. That's the hexa value, and the RD destination register number is gonna be 0. Now for the ALU stage, we have new value for R0. Right? So this new R0 is available right here, and then we need to feed that in to the first register. So this is the source AE is the R0, source BE is gonna be the second one, which is number 60. So we need to get this into here. So this is 24. And the second input of this ALU is going to be 60. So number 60. So we're going to add this two number a little bit later. First, we have forward AE. This guy should be what? 10. Forward PE. This guy should be don't care, because really don't care, because the second input is coming from immediate extent. number 60. And then write data. This is the load, so we don't care. That's only for str. And then destination register number, which is 3. And now ALU result E, adding 24. So let's work on here. So 24 plus 60. So we can convert 60. 16 times 3 will give us 48. 60 times 4 is a 64. So 16 times 3 is a 48. And then we need to add 12 to get 60 in decimal. So we have a 3 and 12 is C. So 60 is 3C. And then we're going to add 2, 4. So that is 5, 12, 16. So it's going to be 60. C is 12. 12 plus 4 is a 16. So 1 carry over. So 3 plus 2 plus 1, which is 6. So that's why it's a 60. Now we are done for the ALU stage. STR stage, we need to have RA1D, which is R1. So it should be 1. And then R2, there's RD. So that should be 4. If you look at the data sheet, RD is 15 through 12. So 15 through 12 is gonna come here. So now let's work on cycle number 6. We already calculate R1 minus 8, right, which is 24. This is 24. And then destination is gonna be 0. This R0 is gonna go, this is 24 and this is 0. We're gonna write that back into register file in the first half cycle, and then we're gonna read the new value because R0 is being read in here, and then 3. Now LDR R060. So we need to locate the memory location R0 plus 60. We said R0 plus 60 is gonna be hex number 60. So that's the number 60 is fit in here. And based on this location, we're gonna take out the content of 60, 0x. Take it out from there, and we are going to store that into register 3. And then store, we had R1 as a 2C. So we have R1 has a 2C. So 64, we said 16 times 4 is 64. That means 64 is equal to hexa 40. So 40 plus 2C, then we end up getting 6C. We have the source A is the first one, which is contents of R1, that is 2C. Second one is source BE, should be number 64, and we said 64 is hex 40, and then result is gonna be hex 6C, and 2C is coming from register, right? And 40 is coming from immediate. And then we're gonna write what into memory location OX6C, that is for register 4. Register 4, which is the double A. So 0xAA is going to be the write data E, and that is coming from the register. Therefore, forward A is going to be 0, and forward B is going to be 0 as well. Now, cycle number 7. So in cycle number 7, LDR is going to be in the final stage, which is the write back. We read content of memory, so it's going to be 0x33. So that is 33. That's going to go to the register where 3. For the store instruction, we're going to store the write data, right? What was the value? 0xAA, that's here, and then where the memory location right there. Okay, that means there's no ALU out M, there is no WA3M or R2, R0, R3. The first one is gonna be R0. And what is our R0? Updated R0 24. Second one, R3. We had a new value for R3, which is 33. We need to get that one from the second one. That is 33. That means the first forward A is gonna be 0. Second one is gonna be 1. And we need to OR these two. The write data E, nothing. This is gonna be 2. ALE result, we have 2400100100, and the 3300110011. We need to do OR, so 00110111, which is 3, 7. And there is nothing in the register file. Finally, cycle number 8. Now we have store instruction, and then OR R2, R0, R3. Everything here is don't care, because store instruction ends in the memory access, and then it's not going to do anything. And this ALU out is going to be OX37, and the destination register number is going to be 2. That's the cycle number 8. And cycle number 9, we're going to store this result into register file. So cycle number 9 is the last cycle. Executing these 5 instructions takes 9 cycles.